So I'm going to start off with a word problem, and we're going to translate a word problem into some expressions. And our first problem is there are 40% of fish in a pond are going to be goldfish. So 40% of fish in a pond are going to be goldfish. Another way of saying 40% is 2/5. So 40% is the same thing as 2/5 because 40% equals 0.4 as a decimal, and 0.4 as a decimal is 2/5 as a fraction. Okay, so 40% of the fish in a pond are goldfish, and the rest are going to be koi fish, K-O-I, koi fish. So that means if 2/5 are goldfish in the pond, that means what's left over is 60%, and 60% as a fraction is 3/5. Okay, so what we can do is we can visually represent that. Since they're all out of fifths, we can designate 2 of those fifths fish is going for goldfish, and then 3 of those fish are going to be koi in the pond. So we can visually represent it like that. We're going to then increase the amount of koi. So a farmer is going to add more koi fish to the pond. The farmer is going to add 10% more koi fish. Okay, so we have a certain amount of koi fish right now, and we're going to add 10% to what is already existing. 10% more koi are going to be there. How many koi are there in the ponds after we add that 10%? So meaning, here's the original amount of koi, then we have to add that 10% more of koi, and so all the koi at the end of the day is going to be the original amount plus 10% more. So we are being asked to represent that amount of koi at the end of the day in terms of G, where we are going to call G the total amount of goldfish. So we're going to say that the total amount of goldfish, we're going to say that this is represented by this big G right here. Okay? So let's use what we have in terms of this illustration to help us out. Do you see that there are, just originally, before we add any koi, for every 3 sections of koi, there are 2 sections of goldfish, meaning for these 3 boxes of koi, there's going to be 2 boxes worth of goldfish, okay? So there's definitely a ratio that's heavy on the koi side, and if we have 3 of this, we've got 2 of that. So 3 sections to 2 sections. We don't know the actual quantities of fish, and we'll never know because we weren't given enough information to figure out, like, there are 24 goldfish and 65 koi. We don't know that. All we know is these ratios, these relative ratios. We know that there's going to be 3 koi sections compared to 2. We don't know how many fish are, now we know that the fish would be evenly divided up between these, but we don't know, if this one block, if each one of these blocks is worth 10 fish or 20 fish or 15 fish. We don't know. And it doesn't even matter for this problem because we're not going to come up with a specific number. Our answer is going to be in terms of G, okay? It's going to be an expression. So we do know that for koi relative to goldfish, do you see that if I were to like rip this out and put it on top of this koi section, these 2 gold squares, and put them on top of what we have for koi, do you see that the koi would surpass the goldfish, all of the goldfish, and then go 1 more block worth? So it would go 2, so these 2 goldfish would be placed on these top of these 2 squares, and there'd be another square left over. So that means that for koi, we could think of koi in terms of goldfish as being there's 1.5 times more koi than there are goldfish, okay? Because you can put all the goldfish on here and still have 1/2 more worth of goldfish to go, okay? So that's why we have 1.5 times as many koi as goldfish, okay? So that could be 1.5, which is 3/2, okay? Which is 3/2, okay? So if we want to talk about how many koi there are, how many koi is going on, we would say, well, there are 1.5 times as many koi as goldfish. So we could multiply 1.5 times the amount of goldfish and get the amount of koi we have. So we could either have it as a mixed number or an improper fraction. Let's use an improper fraction. So 3/2 times g. So 3/2 times g is the amount of koi that we, oh, that's off the, that's off the video. 3/2 times g, the amount of goldfish, is the amount of koi that we have in all, originally, okay? So now we want to add 10% to that. So right now, this is the original amount. This is the original amount of koi that we have in the pond in terms of g, okay? But let's add 10% to that. So how do we find 10% of something? You multiply it by 1/10. Okay, so 10% as a decimal is 0.1. 1/10 can be written as 1/10. So what I need to do is I need to multiply 1/10 times the total amount of koi originally in terms of g to get whatever 10% of that is. Okay, so 1/10 times 3/2 g, 3/2 g will equal, let's see, that's 3/20 g. Okay, so this equals a 10% increase. This is the 10% increase. So if this is the 10% increase, and this is the original amount, then I need to add 3/2 g to 3/20 g to get the total amount of koi that's in the pond after we've added 10% more koi to the pond. So let's do that. Okay, that is just some arithmetic, which we can do. 3/20 g plus 3/2 g. So that's our problem right now. This is the total amount of koi originally plus that 10%. Or originally plus that 10%. So we need to add these. Let's make these with common denominators. So I need to multiply the bottom by 10 to get 20 over here. Whenever I do the bottom, I gotta do the top. And now I have 33/20 g. So that is our answer. That is the total amount of koi in the pond now after that 10% increase. And we'll give you some problems to do on your own now.